Hi, my name is Yagi, and in this video I'll be going over the two fundamental theorems of calculus. So to begin, let's start with the first fundamental theorem that deals with definite integrals. So the first fundamental theorem tells us how to find the area of a function or the definite integral. So it tells us that the integral from b to a of f of x dx, and again what this notation means, it tells us that the area of a function f of x, call this f of x, from the x points a to b, so this area here equals, fundamental theorem of calculus tells us it equals f of x, big F of x, from b to a. So my notation here, what I'm saying is I'm saying that the function f of x, the antiderivative of that function, big F of x, from b to a is equal to that area. What does this notation mean from b to a? That means from f b minus f of a. And so that's the fundamental theorem of calculus. Basically, what we have to do is we take the definite integral, and then once we take a definite integral, we use the bounds and we subtract them. So we plug in f of b minus f of a, like so. So let's try to add an example. Let's say we have the question, the integral from 4 to 1 of 3 square root of x dx. So for this question, we can first move out the 3 to the front based on integral rules, and then we can integrate this x to 1/2 dx using the power rule. So by using the power rule, what we get is we get 1/2 plus 1 is 3/2, so x to the 3/2 over 2/3, or over 3/2, which becomes 2/3. This becomes 1. Again, we have to put this inside the integral 4 to 1. And what this ends up being is x to the 3/2 from 4 to 1, which is the same thing as the 4 cubed square root of that minus 1, which is equal to 7. And so that's how we use the fundamental theorem of calculus, the first one. The second fundamental theorem of calculus relates derivatives to integrals, and it tells us that the derivative with respect to x of an integral where the bounds are maybe g of x, or sorry, not g of x, we'll call it h of x, and g of x of the integral we're integrating the function f of t dt. The second fundamental theorem of calculus tells us that this equals the lowercase f, so the same function, but we plug in h of x times h prime of x minus f, plug in g of x times g prime of x. So why is it this relationship still holds? Let's see. So the easy way to think about it is, let's imagine that we integrate this, so we get derivative of, let's call it big prime, we'll call it big F for the antiderivative, so big F of t from h of x to g of x. Now using the fundamental theorem of calculus, we know that this becomes derivative of f of h of x minus f of g of x. So now we have to take derivative of each part, and for each part we use chain rule. So for this one we just get f prime, big F prime, which is just little f of h of x times h prime of x. Same thing with this one, we get f prime, which is little f of g of x times g prime of x. And that's the same thing that we got up there. So using the fundamental theorem of calculus, the first one, we can find out the second one. So let's try out a practice problem now. Let's say we have the question derivative of the integral x to 7 t cubed dt. So for this one, we have a constant, so the constant, the derivative constant is 0, and so what we're left with is just x cubed. Next, let's say we have the question, the derivative of the integral of sine of x, x squared t dt. So for this one, again, take the derivative, so cosine of x, times, we just plug it in, so square root of sine of x, minus, take the derivative, 2x, and plug it in, square root of x squared, which is just x, so we get cosine of x, square root of sine x, minus 2x squared, and that's our final answer. So the second derivative questions are pretty easy, and yeah, that's it. Thank you guys all for watching, and be sure to subscribe for tomorrow's video. Bye.